Today's guest is Ellen Eischen, a professor of mathematics at the University of Oregon. Today she'll tell us all about her career, including a secret math journal she's kept since childhood, all very mysterious. There's also some chat about creativity, collaboration, and an aborted game of leapfrog with the legendary John Conway. I'll also just quickly point out today we'll talk about some of the challenges women face in mathematics and quote some language you might find offensive. In fact, I hope you find it offensive, because it is. But we also thought it was necessary just to convey the story being told. All that's to come, but as we so often do, the story starts at the very beginning.
I'm from New Jersey. I was born in Princeton, New Jersey, and I grew up in Lawrenceville, which is one town over.
So Princeton's like a famous academic place. So you were born?
Yeah, I was born at Princeton Medical Center, which isn't far from Princeton University, but I didn't have any particular connection with the university. It just happened that my parents lived in Lawrenceville and the nearest hospital was in Princeton.
What were you like as a little girl?
I was pretty self-motivated and driven. Yeah, my mom says I resented having to go to nursery school because I had my own crafts projects and I felt like school was getting in the way of my plans, but, had to go because my parents had to go to work. Interested in lots of things, probably pretty typical kid, but maybe a bit driven.
Would there have been any signs at that really early age that you were going to end up being a mathy person? Or?
I don't think there were anything. There wasn't anything to suggest I wouldn't get into math, but I don't think there were huge signs I'd get into it. My dad was a chemical engineer, and so he had a calculator, and my parents like to tell this story about how I was pushing the buttons, but I'm not sure how much that's about math and how much it's little kids like to push buttons.
Yeah.
So my parents are competent at math to some level, but I don't think I don't think anyone was oh, she's going to be a mathematician.
What did your mum do?
She was a systems analyst at that point.
Okay. So they were pretty smart.
Yeah. And I think when I was growing up in school, if I had questions about things for most subjects, it was clear to me, it was chemistry, I'd talk to my dad, or it was a foreign language, I'd talk to my mom, but math was the one thing that I felt like I could talk to either of them about. Okay.
And as you got older, how did you start changing? How did your interest start changing from just wanting to, do craft and press buttons?
I was interested in lots of things, so I think I was a pretty stereotypical little girl. I wanted to be a princess. I liked everything in pink and purple, but I also liked playing. I liked building things. I liked playing with all kinds of toys. And then as I got into school, I think my interests were pretty diverse. I certainly found math much, much, much easier than I found the courses that required more verbal acuity. I don't think I was bad at the other classes, but in my mind they required so much more that I somehow got into my head that I was bad at them and math was somehow easy.
And when you started getting to the sorts of ages where you understand that you have a job when you grow up, what sort of things would you say you wanted to be when you grew up?
I never knew for sure what I wanted to be, but some things along the line, starting when I was little, probably princess ballerina, but then veterinarian for a while because I really liked animals. And artist because I was into crafts. And then as I got older, by the time I was in 6th or 7th grade, I wanted to be a neurologist. And that was because I started getting migraines in 5th grade and I just thought it was really cool what the neurologist could do.
So that's just something you were exposed to a lot, so.
Yeah, exactly. When I graduated from high school, I still wasn't sure what I wanted to do. I started in engineering at Princeton just because people told me it'd be easier to switch out than in, and I didn't know what I wanted to do.
But you've gone from high school to Princeton, so you're obviously doing all right. You obviously were a competent student.
Oh yeah, I did well in all of my classes. Some were I thought math was really easy, and I thought I had to work much harder at courses like English and history. But I was, I think, very driven to just be the best at whatever the thing was.
Tell me about this journal.
Oh, yeah. Okay. So I have had a journal for as long as I can remember. I was trying to think back. The earliest one I can remember, must have been about 7 years old, and it had this puffy, shiny outside. It was pink and lavender, and it had it was a diary. It had a lock with a key, and it's the first one I remember. I think I got it as a present at a birthday party because diaries were popular at that point, and I just have always journaled since then. It started out like a normal journal, and whatever I was musing about, secret thoughts, crushes, like normal journal things. And then at some point I realized I was also making conjectures about math and trying to work out math, and it was all kind of mixed together. And then,
so what's an example? Maybe not a specific example, maybe even a made up example, but what would that look like? What would one of these conjectures or ideas look like if I was reading it?
I was trying to understand prime numbers and what we could say about them. So some of it was trying to like predict them with a formula. So I'd have some polynomials, which you can't generate prime numbers with polynomial, but I didn't know that. And so I'd be like, well, what if I do this? Or what if I restrict to prime numbers, like when you divide by 4, the remainder is 1, which would be called congruent to 1 by 4, but I didn't know that language. And then I'd be like, well, what if I look at this visually? Like, what if I write things in a triangle and I do this kind of sieve of Aristophanes thing, but I didn't know that word either. But I write things in some weird shape. Can I see patterns in numbers that have certain divisibility properties? And then if I if I see that visually, can I write a formula and so on?
And would the next page then be, I think Billy's really cute?
Yeah, more or less, yeah.
Okay, right. So it was this stream of consciousness.
Yeah, but eventually, like in high school, I decided to seperate these.
The academic stuff, was it just mathy, or would it also be like, biology? Or
no, it was just math.
Right.
Yeah, it never occurred to because it wasn't like, just like with starting a journal, it just kind of arose organically. There wasn't a point where I was like, now I'm going to journal about this topic. And so it wasn't like I was like, let me find an academic subject. It was just, I don't know, it became math.
You're enough of a math nerd to be keeping a math journal as a schoolgirl, but you're not thinking, I want to be a mathematician.
I don't think I knew what a mathematician did. So, I went to math class, did well in math class, but I saw it as kind of, math class is you're computing things and it's kind of formulaic. And what I was doing was much more creative and trying to prove things. And
you didn't know that was a potential job?
No, I didn't know that was a job. I did have kind of a weird math education because when I was in high school, I was always bored. I was bored in math class my whole life. And then in 9th grade, my parents went to the parent-teacher conference, and the teacher complained to them that I looked really bored and it was distracting that I looked so bored in class.
Distracting for the teacher?
Yeah.
Right.
And so they agreed that they worked out some agreement where I just didn't have to go to class, and I would just take the test at the end of each trimester. So I took 3 tests, and as long as I did fine on them, I could just teach myself.
So you were just teaching yourself out of the textbook?
Yeah. Right. Yeah. And then, well, actually,
How did you feel about that?
It didn't bother me, actually. It's weird. People are like, well, your school wasn't serving you. It was fine because I would just teach myself what I needed to know, and then I would work on a subject that required more work from me. And then I had 1 year in high school, which was a very normal class, but the other years were kind of much more varying degrees of independent study, which I feel was really good preparation. Well, probably the journal was probably good preparation for independent study, and the independent study was certainly good preparation for a career as a research mathematician. But when I got to Princeton, I felt like I had no clue how to learn, or maybe not no clue, but I didn't have very good skills for learning math in a normal classroom, and the classes at Princeton move at a pretty good clip, so I had to learn that skill later.
When you're applying for universities, though, is anyone saying to you, oh, Ellen, you're really good at math. Why don't you go and do math at Princeton or somewhere else? Is there no one that recognizing this yet?
I think people recognized that my school would give out these subject awards each year, and I would win the math award. And it was in an unusual situation. I went to a small high school, and it was about 2/3 guys, but the advanced math and science classes were dominated by women. And so it wasn't like there was any sort of bias or anything against me. I got encouragement, but I just don't think I'd been exposed to what a mathematician does. So in my mind, it was like and I knew my dad was an engineer. In my mind, engineering, like I had much more of a sense of what an engineer was. I signed up for a multivariable calculus class for students who came in knowing some math, but were planning to be engineers. And I had a bunch of friends who were complaining about their proofs class, and I would see what they were doing. I was like, that looks like what I want to be learning. So since I'd taken enough math in high school that I had some advanced standing, I could go take that proofs class in the spring without jeopardizing anything for my engineering education. And so I took that class. And
even though your exposure to it was people complaining about it.
Yeah, but I could see what they're complaining about. And I was like, I want to do those problems. So yeah, I took the class and I really liked it. And then sometime during the semester, I went to my professor and because I was like, oh, maybe I can show my journal. The journal was secret, I should mention, in high school. So no one would have been like...
Even the math one that didn't have...
The math was almost entirely secret. There were like a few teachers I showed at like late in high school because I don't know why. But it was basically more or less secret except for a few privileged people. So I brought my journal to my professor for this proofs class, and I had something I was trying to figure out, and I asked her, and she said, I don't know, but you should talk to this other professor named John Conway. And so
And had you heard that name before? Or
I had heard it because I'd also heard people complain when they were intimidated in his class, and I'd had a friend who had been in his class for a week at the beginning of freshman year and dropped it to take a different class. I didn't know about him as a mathematician and how he's really famous. I knew about him mainly in the context of first-year students at Princeton complaining about classes, just like the class I had signed up for.
There was no embarrassment or cringiness about taking your high school girl journal to these professors at all? And
I only took the math. I only took this was a separate math one.
I understand. I understand you weren't showing them, cute Billy or anything.
Yeah.
But still, like, I imagine there was a degree of naivety to your high school thinking.
Yeah. Oh, yeah.
And you weren't embarrassed by that. You were like, I still want to show it to them,
I think I was nervous, but I was like, oh, the professor who's teaching my proofs class, who ironically, I was at MSRI in the fall, and she was my assigned office mate in the fall.
All right. Years later.
So, yeah.
So anyway, so you've got this journal.
Yeah.
Your professor has said, show it to John Conway. What do you do next?
I went to back to my dorm room and I emailed him, and he wrote back, and he said, "Oh, I must have mentioned something about what I was interested in there because he sent me a question to think about." And I made an appointment and I went to see him like maybe a day or so later.
Just like at his office, or?
Yeah, he was at the restroom when I arrived. And then I bent over to look, I don't know, something in my backpack, and he came bounding down the hall, and he's, a big guy, and he suddenly yelled, "Leapfrog!" And I bolted up because this is in Fine Hall in the math building. No one runs down the hall. You say leapfrog, and he was like, "Oh, you stood up. I was going to jump." And
he was going to leapfrog over you.
Yeah, this was my introduction to John Conway.
Okay. So you didn't get the leapfrog because you stood up?
Yes,
okay.
Yes.
All right. So after that, you pull out your journal, and did he look at it and go and think, this is trivial, or did he praise your journal, or what did he say when he was looking at it?
So he said, let's sit down, and there's these nooks in the hall, in Fine Hall, and he said, let's look at this. And then I was really nervous suddenly because he was really looking, and that just vulnerable, showing, forget if it's your journal, you're showing somebody your thing. And I don't think I really fully grasped who John Conway is, so that helps a lot. Do
you think if you'd known who he was, you wouldn't have taken your journal to him?
I have no idea, because I don't think that's like outside my context when I was like a teenager. So I don't know.
Okay.
I mean, I'm a pretty brave person with approaching random people. So I don't know. He looked at it carefully and then released some pieces and talked to me about some math. He was actually very encouraging. And yeah, he said some very encouraging things. Then as we talked, he also though told me if I wanted to be a math major, I would need to learn a lot more math because I didn't have, probably at most colleges, I had a strong background coming in, but like students coming to Princeton, especially then it was a relatively small major, tended to have like, they'd been on like math Olympiads, or there were like a lot of students who came in with like just stuff that was totally outside my context. But he was very encouraging. And so that was very exciting to me because it was like the first time someone was actually looking and actually reading and commenting. And yeah, that was like exhilarating, I would say.
How long after that did you make the switch?
Couldn't have been more than several weeks. And when I went to the dean of the engineering school, and like his, or associate dean, his job was basically, I think, partly to keep people staying in engineering because it's very common for people to leave engineering. And the big reason they leave is they don't like math, that they're intimidated by their math classes. And so I had heard beforehand that it could be very hard to switch out because he argues with you, but he basically was very happy it was math. And he just said, just promise me that when you're teaching engineering majors someday, you won't turn them off to engineering.
Because you were flipping out of engineering for the right reason, in his opinion, probably.
Yeah.
And then when you made that change, because you'd been warned maybe you didn't have some of the weapons you would need to be a math major yet, was that scary or intimidating, or did you love it?
I think I, again, didn't have the context to realize what I was getting into, and it was really, in the fall when I came back, it was really hard for me. Yeah, I just didn't have the background, so it was a lot of work to get caught up, but I was lucky because one of my classes was taught by John Conway, and I just really liked his whole style and the big character, and so that was a linear algebra class that at least felt somehow fulfilling in a way. And then, but I did struggle a lot to find my footing.
What do you do when that happens? Do you just like go away and cry in a room and then get a whole bunch of books out of the library? Or are there people you can go to teach you to plug the gaps? Like what does one do when they're in that kind of deep end?
Well, I mean, as a professor now, I would tell students to go talk to other people and try to that it's good both to try explaining your questions or explaining what you understand otherwise to someone else, and vice versa. It's good for students to do that for you. But I hadn't really ever struggled academically really in any real sense in anything before I got to Princeton. And so I don't think I had developed those skills. And so I did spend a lot of time crying by myself in a room, which is not very effective. Eventually I learned to ask questions, but I also worked by myself a lot. I became more deliberate about making notes about what it was I didn't know so I could go fill in later. Yeah, I didn't talk to people as much as I would recommend.
At what point through this 3-year education did you start to think about what you wanted to do with this education? Did you start to think, am I going to go and work on Wall Street? Am I going to go back into engineering? Am I going to be a school teacher? Am I going to be a professor? When did you start thinking about what you wanted to be?
So I think all through college I was stressed about what I wanted to be, but I never had a moment where I was like, this is what I'm going to be, but the time just keeps going on, and eventually you graduate and you have to do something. And so that thing for me was, I guess I'll keep learning number theory, which I was interested in. So I applied to grad school and kept learning number theory, but I'm not one of these people. I've never had this kind of epiphany where it was like, this is the job, and then it's a straight line. It's an unrelatable experience to me.
Some people I've spoken to talk about how they did math at school and it was about solving problems and things like that. And then they get to university and suddenly they're exposed to some of the beauty of math, the proof, what it kind of really is for professional mathematicians. It sounds like you were already craving that. If you've got this journal where you're thinking about prime numbers and that, it sounds like university was exactly what you were looking for.
Oh, yeah. Yeah, I didn't know that until I got there. I didn't know that. And I have to say, yeah, it was great. I met with John Conway this one time, but I met with him many times after that. And so that was also great that there was this encouraging but realistic person to talk to about just random questions.
Did you ever do the leapfrog?
No, we didn't actually. Sorry. Let down.
Never got there. So why your specialization's number theory, is that right?
Yeah.
Why? What happened? What was the hook to get you into that of all the different specializations you could have had?
Yeah, so the hook that got me in is very different from what's kept me in now. So the hook was they had these questions about prime numbers and whole numbers and factorization. And so the questions I was interested in turned out to be number theory. And Princeton was very strong in number theory. I had the opportunity, once I kind of found my footing, to take classes where I got exposed to lots of techniques that are important in number theory. I got all undergrads do a senior thesis, and I got to do my senior thesis with Andrew Wiles. It was like just several years after the proof of Fermat's theorem, so that was pretty cool.
What was he, your supervisor, or?
He was my senior thesis advisor.
God, you're brushing shoulders with some big names.
Yeah.
Nice.
But if you asked me now, I work in the particular area I work in, it's really because, like, you might have figured out I'm a little indecisive about what I'm going to do. And so I work in an area where we get to use lots of different flavors of math. And I really enjoy math that, like, builds bridges between problems that a priori appear to be completely different and then links them. That's the kind of thing I do.
As mathematics advances further and further, it feels like the various areas of specialization become more and more complicated, they become huge, they become these huge things. And one specialist in mathematics could probably feel completely out of their depth in another specialization because they just don't know the language and what's happening there. Does that make it, in the modern era, really hard to be that kind of all-rounder you're talking about? Because if you want to go and borrow from some other field of mathematics, that's like a huge thing for you to have to learn. Oh,
yeah. So you kind of have to... My view is, like, you start somewhere, you know some things, and you kind of follow the trail where it leads, or I'm sitting where I am, but I think there's some parallels with something else, and so you start to kind of fill in the pieces. So it's a lot of work, and it's a different kind of experience from someone who's decided I'm going to, like, really specialize in this subfield of abstract algebra or something. But I don't know. This is what I want to do. So.
All right, you got to do it. What does doing mathematics look like for you? Like, if you want to solve a problem or come up with an idea and write a paper, like, where do you start? Do you sit on the sofa with a notepad? Do you go for a swim? Do you like to walk in the forest? How do you come up with new stuff?
A little bit of everything you're saying, but there's a math journal involved also. So I still have a math journal, but it's very different. My math journal now, I type, and it's much faster to come up with a question or problem or idea than to actually carry it out. So at the beginning of it, I have a list of problems, which usually arose while I was, like, stuck on a particular problem, or I was working on things like, wouldn't be interesting to explore this other thing, but I'm not going to go down that route right now. So it usually starts with, like, I know what most of the things I'm going to work on are for the next the list is growing, but I have a pretty good sense of, and this is maybe different from a lot of people I talk to, but I have a pretty good sense of what the general problems are I'm gonna work on, even like the narrowed down versions, modulo maybe something getting added to this list or somebody solving something that's on the list. And so I'm, like, kind of thinking about them in the back of my mind, even when I'm not working on them. But then when something makes it to the top of the queue, sometimes it's working with stuff on paper, reading about things. I like to kind of notice parallels, like, where was there something maybe similar? Like, what kind of structure carries over between what I'm trying to do and what's been done. Also work with collaborators sometimes, so talking to them on Zoom or in person. And yeah, I go for a lot of walks, and there's also swimming sometimes, as you mentioned.
Can you remember a time or a specific time or a place you've been, or a trigger for one of your, like, real moments, one of your breakthroughs? Obviously you have a few of these, through your career. Hopefully you have many of them. But can you remember one? Can it be like walking across a bridge or looking at a cloud, or is it a more slow process?
There's something I remember, but it's usually pretty slow, but there is one I remember, and it's not so romantic, though. I was in my postdoc and really stressed because I was a postdoc at Northwestern University. You're in your postdoc for 3 years, and you have to apply for a job at the end, so you're really in a time crunch to produce papers, and you start that after your PhD, so you don't really have any publication record. So I was already stressed, and then I got really sick. I was working on my first paper post my PhD thesis, and I got really sick. I'd been stuck on something for a while, and I don't know whether it was just like that I was delirious because of sick, or it was the medicine I was taking, but I suddenly everything like fell into place. And it was still true when I was well. So but it's not very romantic.
On your sickbed?
I was well enough to get up to like go to my desk. But while sick and not,
You got to look up what those drugs were. Maybe magic drugs.
Yeah. I don't have any good stories, though, where I was like, the sun set and I'm looking out that never happens.
Oh, well, you got to do what you got to do.
Yeah.
You said at high school it was the girls who were the top mathematicians, the top math students.
In general, yeah.
What's been your experience as a woman doing math then through Princeton and grad school? Has that remained the case, or like what's
it was completely different at Princeton, and I had heard I heard for years, you're good at math. You asked in high school people say I'm good at math, and they say yeah, and they're like, that's going to be great for colleges because it's so hard to get women who are good in math, and like it was so far from my experience. They may as well have been describing like some other foreign country, some other era. Like my experience up until college was women excelling at math and science, and I don't remember ever experiencing a comment from anyone to the effect that like that shouldn't be the case. And then I got to Princeton, it was totally different. There were very few women in the math department. So like this proofs class, I can't remember, there might have been one other woman or it was just me. I mean, it was normal to be either the only woman or one of very few women. And it felt totally different from my experience up until that point. And
how do you feel about that?
I feel sad about it. I feel angry, especially because there's no good reason for it. Like I just seen in my high school that it was totally different. And I think math is really great and can be very joyful. And it's like not good for the individuals who are maybe being kept away from really cool stuff. And it's also not good for the field because you're limiting its development by keeping a bunch of people away. Either, even if not overtly, by not maybe having a culture that's conducive to or more welcoming to having more people.
How did it affect your ability to learn mathematics being so dramatically outnumbered?
It actually had a huge impact, and this is weird to say because I get a lot of, I think I maybe compartmentalize things well a lot, and so I've had senior male mathematicians say to me like, oh, I can't believe I heard about this, like, do you know that so-and-so who is like much senior to me experienced sexism in their career? And I'll be like, I'm not surprised. And like, of course you never experienced anything like that. And I think I just somehow maybe the appearance on the outside is different, but it was very hard for me. And
why? Tell me what it's like going into college each day.
There were some people who would say who comment on my gender, and I think sometimes they thought they were doing it in a flattering way, but maybe didn't have very good social skills. And I don't know if I can say this on a podcast, but someone who I felt was my friend in the department just said to me, "You're the only pussy in the math department." And so you can decide what to do with that. But you begin to feel like you're outside. And the effect that has is it's weird. It's much bigger than I feel like it should, because I feel like you should be able to somehow rationalize and be like, oh, well, this thing or that thing is just nonsense. But it really gets under your skin. And I think that's a very common experience. And then I felt like, oh, I have to super duper excel at what I'm doing to be taken seriously. And that may or may not have been true, but it's certainly what I felt. And I think that's a very common experience I hear from people who are underrepresented in their fields. I ended up doing very well. Like I won some prize when I graduated, and I graduated Phi Beta Kappa. So like I did and summa cum laude, so I did very well. But I think some of that was maybe driven by feeling like there was no room to show any kind of weakness.
Since then, I mean, obviously you've now moved through the ranks of mathematics. You're a senior mathematician running programs here.
Yeah.
Does it still feel like a big problem?
I think it's still a big problem, but I think things have changed, like improved a lot. Even during my lifetime, there are way more women now at conferences than there used to be. And like I have a picture, for instance, of some annual workshop I went to in 2007 as a grad student, and then that I lectured at a year ago. And like the 2007 one, there's almost no women in this crowd of people. And then a year ago, there's still more men than women, but way more women than there had been 15 years earlier. And this is partly due to various deliberate programs. So I was part of something called Women in Numbers, which started in 2008. There were 3 women mathematicians so Rachel Prees, Renata Scheidler, and Kristen Lauter. They had noticed at a conference that there were, in number theory, that I can't remember, there were no women speakers, and they're like, this is early 2000s, and they're like, this is outrageous. And so they went and started to make a list of all the tenured women active in research in number theory, like on a napkin or something, and they came up with 3 names. And they're like, oh, well, you can't expect like 3 people to cover everything. And they decided to start a workshop, which still runs every 3 years and has grown to other fields, to promote new research collaborations between women. And so I led a project at this in 2014, and it was really impactful in my career. And I think programs like that have a really big impact on increasing visibility of women doing actual research, as opposed to kind of putting up posters of women or having panels, which are also valuable. But the reality is, like, having people see papers appear on the archive by groups of women and seeing those get published in good math journals has a real impact. I actually, inspired by that, this past summer, I organized a workshop in my research field that facilitated new diverse collaborations in which women were not the only people in the collaboration, but they were a majority. So it's basically minority-majority collaborations, and that seems to have gone well.
It feels like one of the problems was that leap from high school to top maths departments.
Yes.
I can't see how more women publishing papers on the archive will help with that, because high school girls don't care about who's publishing papers.
I think it affects the climate, though, because the people who are teaching those students become aware of women mathematicians. So I think, suppose you're like, well, recruiting and retaining women is important, but like, you never work with another woman, you never use another woman's results. All you do is train them. You probably, like, your image of what's even going to happen with these students is different. And so it changes people's perception of like what a mathematician is, what a mathematician looks like, who can become a mathematician. And so I think it really does impact the culture. So I think the atmosphere has changed a lot. Certainly the percentage of women in math has increased a lot. I also feel like as I've gone further along, some of the kind of petty little comments just disappear. I only know that they still happen because I hear from younger women about things, and I'm like, really? I would have had no idea about that. But at the same time, I find that sometimes like the nature of the comments changes. So if you become more accomplished, some people then accept, oh, okay, you can do math, even if it's maybe an exception in their mind. But for other people, it suddenly is like they come up with a reason to discount it. Like, oh, but it must have been this or it must have been that, but she couldn't really have done this thing. Somehow I think I had this illusion that, oh, I just have to put my head down, like, just do my thing, achieve, and then I'm going to reach that, like, that promised point. And I don't think that point can maybe exist internally, like you gain confidence and so you're like more immune to what's happening externally. But I mean, it's kind of like haters are gonna hate, or like regardless.
For someone listening, like male or female, just someone
Yeah.
who's thinking about mathematics, what's it like being a professional mathematician, like as a job?
Sometimes it's great, sometimes it's like awful, and I'm like, what am I doing? Because I think it's similar to lots of other kinds of research in that you spend a lot of time failing, and that doesn't always feel so great. But when things are like making sense and going well, or when you get to be at a place like MSRI, or SL Math now, has been really like a really awesome atmosphere, then it feels pretty good.
Do you ever wish or daydream about doing something else?
Sometimes I do, but it's never been like, again, I never had a specific like thing. I'm not one of these people who's like, oh, if I wasn't a mathematician, I would have followed this other career path. Like sometimes I'm like, oh, what if I had followed that path of becoming a neurologist? And in some ways I'm like, oh, that would have been better. And in other ways I'm like, oh, that would have been such a drag. Like I have a lot of interests, so I'll just be like, oh, wouldn't it be interesting to, like be a Broadway performer or something? But I'm not one of these people who's like, if I didn't do X, then I do Y, because I never even had this epiphany in the first place of what I was supposed to be doing.
Do you do much teaching?
It varies. Yeah, I do teach. I teach a range of students from undergrads to grad students. I'm on sabbatical right now. So at the moment, I'm just advising my PhD students. But I teach all levels. And actually, maybe I'll tell you about a course I'm particularly excited about. So I designed this new course called Math and the Creative Process. And I really like that it introduces students early in their education who don't have a lot of background to the creative side of math, because that's kind of what I think is really exciting about math. And students who are early on, especially at like a big school like Oregon, it's not Princeton. They don't necessarily come in like, oh yeah, I know all about what math is. And so it's nice to expose them to kind of beauty of math and the creative side of math. And we do a lot of like visualizations. And I also incorporated, so maybe this is a whole separate topic, but when I was a postdoc, I started studying improvisational theater. And I've incorporated or adapted some exercises from that into this class, and it's just a lot of fun.
If you're a professional mathematician,
Yeah.
and you're not creative at all,
Yeah.
what are you even doing? Like, what are you actually doing every day?
If you're not creative, what do you mean?
Because isn't a professional mathematician's job to come up with new stuff? To prove things, to find new paths. If you're not doing creativity, what are you actually doing?
I don't know. I don't know. I don't know. But I think for incoming undergrads, they don't think math creativity in general.
What does improv mathematics look like?
Okay, so we're not really improvising mathematics, but developing skills with them for communicating, taking risks, making mistakes, noticing patterns, building on them. And what I noticed was with a lot of like students, especially early on, they were like freezing. They'd be like, well, what do you want? I don't know. And there's this anxiety specific to math, but you can go have a conversation about something else and they're suddenly fine. It's not like they're anxious people, just anxious about math. And often even students are planning to be math majors. Still, there's like this freezing. And so I was like, well, maybe I can take some of these exercises. We're going to do an improv exercise first. I can tell you about an example if you want, so it's less abstract. And then, okay, what skills did we use there? Okay, how can we take these skills in this thing that you all just thought was fun and nobody seemed particularly stressed about, and now how are we going to take this into like collaborating on this project that we're going to work on together?
So give me a practical example of like a fun game that you then twist on them.
So something to do at the beginning when because in this course they have to, I'll give you two examples actually. The first one is something, it's pretty common early in improv or theater class called one-word story, where do you know this? Or I'll tell you how it goes so your listeners know if you play this. So one-word story, and I tweak this slightly, so it's basically a how-to manual. And so I would say this, you say is, I say how, you say you, and then we would have already asked for a topic and something like brush your teeth or something, and they have to say how to do something that anyone would know, but they're doing this exercise back and forth,
Alternate.
one word at a time.
Alternating.
Yeah. Yes. Yes. And it's like pretty funny. Usually then I'm like, okay, how did it go? And the whole thing is they're having their experience. So I'm not like telling, they could say anything, but they tend to be themes in how they respond. And then I'm like, how was it? And they're like, oh, it was really fun or funny. And I'm like, what? Well, some of them are like, it was hard. And then I'm like, okay, well, what skills did you use? And they're like, oh, it was so hard because I was like, something that happens frequently, there'll be somebody who's like, I kept trying to predict the whole sentence and I had to like keep recalibrating.
Yeah, because you've got an idea where you want it to go and then the other person's pulling it in their direction.
Yeah. And then maybe they'll be like, I got stuck with all the boring words, like the ands and buts or a or the, or I couldn't come up with a word. Or another thing that's really common is they both have like a legitimate idea of how to do this simple task, but it's not the same. And that causes like this immense amount of confusion. And
you brush your teeth in a different way to the other person.
Yeah. Or even just something about like the order. Like, do you fill your glass with water first or after when you have to rinse? Or like basic things that if you saw another person do, you would recognize it as correct, but it's not how you would explain it. So then like we'll have this conversation. This takes a while, so I can only do like one of these a week, and that course is 4 hours a week. And then I'll be like, okay, so like, what do these skills have to do with what we're about to do, working on these problems? And so we'll talk about how there can be like multiple ways. And you really have to, one of the things they know is you really have to be like present in the moment, not planning, not have your whole formula for like, it's this, and this, and this, but being present with the other person and incorporating their ideas. And
so it's more about the skills they've learned. Yeah. You don't then say, okay, now do a one-word explanation of the Riemann hypothesis.
No, I've never done that. People have asked, and I like someone in my department said they were going to try this for like a game for reviewing for tests, but I've never done that. And I intentionally don't put anyone like on the spot with weird topics. But they're mostly just about developing skills that can be useful. They're definitely translatable well beyond the math. Yeah, they're useful beyond math. But there's the thing, like, if I were to come into the room, it would be faster if I were like, okay, now listen to your partner, like, be present. Listen to other people's ideas. It's not all about your idea. They might have something to add. It just would go over their heads. Like, it's not
It just sounds like platitudes and like hollow statements.
Yeah. And you realize when you're doing this, like, how bad you can be. If you're not in the moment, like, how bad you can be. And so I'll have, like, little things like that I work in.
That's cool. That's really interesting. What do your other mathematicians think of that, bringing these sort of trendy theatrical ideas into math?
I think it ranges from just they tolerate it, like, okay, whatever, it's just some weird thing, to being interested in it. So actually I'd wanted to design a course like this for a long time, but I was also worried and maybe it would be a lot of work, and there's another part to this Math in the Creative Process course, which I'll get into. And I thought also it might fall flat doing something like this, because having like studied been a student in a lot of improv classes and having taught math doesn't actually prepare you that well for teaching improv. It's like, feels very different, even like little exercises like this. About 5 years ago, I got a National Science Foundation Career Grant, which is this big 5-year grant that funds research and education and outreach activities. And as part of it, I was able to hire a consultant from Chicago, which is like the center of the improv world. And in addition, and so her name's Heather Barnes, and she runs a little company, Improv at Work. And she was and at the time she was an instructor at Second City. She'd also run the Center for Advancement of Science Education at the Museum of Science and Industry in Chicago for over a decade. And I worked with her and she had a lot of experience using improv techniques to help scientists and mathematicians with STEM communication. And so I reached out to her and I was like, hey, I'm applying for this grant. I'm probably not going to get it, so I don't want to get too much into this. But if I get it and I have funding, would you be willing? So she was like, okay. And then I got it, and we've worked together, and it's gone really well. And in fact, you were asking what people think. I do get requests from people like outside my university to like run workshops, and I just got more funding for the next 3 years. I was just talking to her a few days ago. We're figuring out what we're going to do, but we are developing like workshops to bring other people. So I'm really excited about that.
Are the workshops with that same aim of getting like STEM type people to start using these skills?
They'll be aimed at both developing pedagogy techniques and more broadly STEM communication. They'll be though for like grad students and faculty.
You told me about this hit list you have is it in your journal, the things you want, things you like. Do you like keep that a secret from other mathematicians? Is it like kind of a secret thing? It's
secret, but like there's not. It's most of the problems on there aren't things that like if they were. They're not like Riemann hypothesis type things. Like they just, unless you're really close to my area, I don't think it would register as anything interesting. It's just secret because I don't want to edit. I don't edit anything in there. And so it's like I have an idea, I throw it in, but maybe a year later I like add some entries, that's it. I just wrote something it's never going to go anywhere, but other things I have something. Sometimes even I'll hear a talk of somebody at a conference and I'll be like, oh, maybe that would be a good collaborator for this piece of the project. I like put their name in there. There's people who probably have their names there who have no idea. So it's secret, but just, again, it's just because I don't want to have to edit it, not anything exciting.
Because you mentioned, obviously, you were supervised by Andrew Wiles.
Yeah.
Who was famously secretive about something he was working on. Yeah. But you are this kind of, it sounds like you're this like ultra collaborator who's just all about collaboration. So none of that's rubbed off on you. You're not secretive.
No, but I wouldn't call myself an ultra collaborator. I really enjoy collaborating, but I noticed, so recently I was on a panel here at SL Math about collaboration. And after it, I was like, looking at websites. I think something that's kind of unusual about my record is about approximately half of my papers are written collaboratively and I write about half independently. And most people, if you look, they either write essentially all their papers collaboratively or almost everything independently. So I think I have a very unusual mix. It wasn't something I set out to do, but I would say at any time probably I'm working on something independently and something collaboratively. So I don't know, I think of someone who's an ultra collaborator as being somebody who is kind of working more exclusively collaboratively.
When you finish doing math, maybe you never will, but when you come to the end, whatever the end looks like, what will success look like? What do you hope to have achieved when you look back?
Again, this goes to my my not quite knowing. I have no epiphany about that, but I want to feel like I've contributed to my community, and also like I want to feel like I've contributed to a broader community. So not just what people in my field of number theory are doing, but like broader things. Maybe I can tell you about this museum project because the thing I've done in my career that I thought was the most fulfilling and that I'm most proud of actually is not my research. On this NSF career grant, I asked for funds to have a museum exhibit. And I said that the students in this Math and the Creative Process class would contribute some of the work to the museum exhibit. And so before I applied for the grant, I also reached out to the museum and is like, I'm probably not going to get this, but I had this idea for this museum exhibit for like years beforehand. And I was like, so I really want to do this. I was like, I don't know how these curators are going to respond because I wrote to our art museum on campus, the Jordan Schnitzer Museum of Art. They were really excited. And so like, let's meet. So I was like, I want to have an exhibit, and I want it to be an art museum, not a science museum, because I want people to see a creative side of math who wouldn't go to anything labeled math or science necessarily.
You didn't want to be preaching to the choir.
Yeah, exactly. I wanted them to just see this side. And then we had like, when it all came together, there were QR codes next to like the names of the students or math artists, and people who are interested could go to that and they would get like lots of information, which my students had to write and the other contributors had to write. They were like, okay, sure, we can do this. And I got the funds, and I thought they were going to, like, once I got the funding, be like, just kidding. But they were like, sure, we can move ahead. And they were like super supportive. It was probably like, it was one of the best collaborations I've ever been part of, working with the people at this museum. And
so what were the exhibits? What did you make?
We had some stuff with roots of polynomials that formed interesting patterns. We had
these like two
the prints. The prints, yeah.
Like, okay.
Yes, and I found out museum people really care about the materials. So in case there's any listening, there are prints on metal, prints on paper, and prints on acrylic. It's like the first thing I would always get asked is what materials these are. Most of them were metal, but there were, some on paper, some on acrylic.
So what's an example? You'd take some polynomial and sort of plot it, would you? Or
Oh, yeah. So exploring the zeros in the complex plane of some families of polynomials. The students I gave them some starting code and starting points, but then they would experiment with it and get really cool patterns. And then they had
sort of Mandelbrot set type prettiness?
They're pretty, but they weren't the Mandelbrot set specifically. Yeah. But yeah, like they look attractive and like something that would draw you in. If you didn't know that they were math, then you'd just be like, oh, that's cool. Or maybe, hopefully, you'd be like, that's cool. What is it? And this museum, it's really amazing. Oregon gets a lot more art than people might expect, because you think of like New York or maybe LA, and as far as U.S. cities. And there's some kind of tax code that makes it advantageous for wealthy people to leave their art in the state of Oregon for a certain amount of time. So if you're like a wealthy person here in California, you leave it in Oregon for a bit. But if you've just spent like $40 million buying your one piece of art, you're going to be pretty careful about where you put it. And this Jordan Schnitzer Museum of Art on campus is one of the like destinations. So like there was Warhol around the corner, or like I took my class there last spring and there's a big Basquiat on the wall. And so we had like our student display, but there's also like serious art, which is kind of mind-blowing.
You said you didn't want to be preaching to the
Oh, yeah.
You wanted this to be an art museum so that you would expose non-mathematical people to mathematics. Do you feel like that worked? Do you feel like people came in and looked... Like, obviously they would look at these things and think they're striking, but do you think they were scanning the QR codes and really processing the functions and the polynomials? And
So I don't know to what degree they did that, but I have a website that linked to it, which was holding these, and the QR codes, I don't know. I have a website, but there's another thing that happened. Because of COVID, in addition to the 3-month in-person exhibit, it was just when things were beginning to open back up. They also set up virtual exhibits for some of the museum stuff. And so we also had this online virtual exhibit, and it was supposed to run concurrently and then end. It's actually you can still access it online. It quickly became the museum's most visited virtual exhibit. And so it's visited by something like 57 countries and 463 cities. And people definitely were interested.
But do you think they were just looking at pretty pictures, or do you think they were like going deeper?
Probably some were just looking at pretty pictures, but like I got a message from somebody. She was like a woman in her 80s, and she was like, somebody has to make a Nova special about this. Like, why did I not know? I didn't know this is math. And like somebody has to tell people. And so there are some people, I think, like almost outrage that like, why is this? Why do they not know? Of course, like if you knew to look, right, you go on the internet and find tons of really cool visual and math stuff out there. But if you don't even know to look in the first place, then you just don't know. So yeah, I think for some people, probably it was just some pictures and they moved on. And for some people, it was more.
The last question I want to ask, do you now teach engineering students?
No, because we don't have an engineering school. So, or I guess they just added some engineering programs, but it's very new. So far, no.
So you haven't yet made good on that promise?
I haven't really had a lot of opportunities to make good on it.
Maybe the time will come.
Yeah.
I'll include some links to Ellen's work and other stuff we discussed in the notes for the show. I'm Brady Harron, and you've been listening to the Numberphile podcast.